Alright, hello everybody. This is a supplementary video for our osmosis lab in Biology 105. Sorry for the infinite hallway going on right here. Let me get our Excel file up. Alright, so you this week weighed some potatoes, put them in solutions containing different concentrations of salt, and then weighed the potatoes again. You also took cores of potatoes, measured their length, put them in salt, and then took them out and measured their length again. This is to emphasize concepts of osmosis, which have all been run through in the pre-lab video, so I'm not going to really talk a lot about that, but I want to talk to you about how we're determining the isotonic point. Okay? So what you're looking at right here is an Excel sheet that just has some raw data, right? It tells you the percentage of sodium chloride, alrighty, in the solution. It tells you the weight of the potato before it went into that solution, and then the weight of the potato after it was in that solution. Okay? Now, analyzing this is not that complicated. What we're trying to find is the point where the weight no longer changes. So you can look at this data and compare before and after weights and see that at very high concentrations of sodium chloride, all right, the weight goes down of the potato core. That's because water is flowing out of the potato because the solution is hypertonic and water's flowing towards the area of higher solute concentration. If you look here at the other end with the pure water, the potato core is getting heavier because water is flowing into the potato core because the solution outside of the potato is hypotonic. Now what we want to know, that is where is the isotonic point? What's the point where the solution outside the potato is the same tonicity as the solution inside of the potato? So you'll see right here, around 1 and 0.5% sodium chloride, you see minimal changes in the weight of the potato. So just looking at this raw data, you can see, okay, now 1% sodium chloride, mass is being lost from the potato, water is flowing out, but at 0.5% sodium chloride, mass is being gained and water is flowing in. So you know already that the isotonic point is going to be somewhere between 1 and 0.5% sodium chloride. How do we actually figure that out how do we figure that out more accurately instead of just estimating somewhere between 0.5 and 1? Well, we use a line with an equation that looks like this. So this Excel sheet is in your Canvas module, and it's called Graph Your Potato Data for Fun. And I encourage you to take your lab data and type it into this Excel sheet, which I've already set up to do all of the necessary calculations for you, and then generate graphs, okay, including line equations, so you can see the isotonic point that your data determines. I really suggest you do this activity because there will be a question about the isotonic point on your actual exam, your lab midterm, and your lab final, okay? So look at what I've done here. I've put that same data into this table. You've got the weights before and the weights after. Now, what we're looking for is the percent change in weight. And it's a little small, a little difficult to see, but the equation for percent change in weight, all right, is the after mass, all right, the weight after, minus the weight before, divided by the weight before, okay? You'll see what this means right here, right? You can see that when the weight goes down, the number is a negative. It's a negative percent. What it says is that you lost 16% of the initial weight. All right? Down here, this value indicates that you gain 8% of the initial weight. That's what we're talking about with percent difference or percent change. All right? You'll see that value presented all the time. It's good to know what it is. So I set up Excel to do that math for us, and now I've got the percent differences. Now, this experiment included replicates, which is great, so I've also told Excel to take the average of those percent difference values for the same concentration of sodium chloride, so it's more accurate. All right, So we've got the average percent changes over here. Now I told Excel to just take the values from these cells and put those into a nice new table for us. And here we've got the percent change in weight for each percent sodium chloride. Then it's as simple as graphing that, all right? You're essentially making kind of a standard curve here, okay? There's no real difference between this and standard curve generation. You insert a scatter plot. So you would go insert scatter plot up here at the top. You insert a scatter plot and you fit a line to it, a trend line, just like I've taught you already in class. And then you tell it, go to more options, and you tell it that you would like to see the equation on the chart. So it's just that easy to get that standard curve equation, but I've already got it for you right here. So what's the last piece? Well, just like with the standard curve, you could visually estimate, right? You could say, I want to find the point where there's no net change in weight for the potato core. And it's somewhere here, all right? Somewhere around this point, okay? Now, the way that you do this is you just solve for 0 in percent change in weight. So the y-axis, if I just add a quick axis title here, the y-axis would be percent change in weight. And remember, the isotonic point is when the percent change in weight is 0. The x-axis here is the percent NaCl. Oh my gosh, NaCl. I'll get it one of these times. There we go. So just like with the standard curve, right? I want to know what is the value of x when y equals 0. So it's as easy as plugging in y, as plugging in 0 for y. Okay, so you go 0 minus 9.5365 equals this number, divided by 6.0752, and we've just solved for x. Okay? Oh, I forgot to put the negative symbol in there. My bad, negative. That's why we got a positive value. But disregard that, and you'll see that, sure enough, the equation estimates the isotonic point at 1.57, roughly, percent sodium chloride. Now, if we go back to my initial statement here, you saw that, oh, visually I estimated that the change would be, somewhere between 1 and 0.5. Now, this is because the data that I put in here is just data that I made up, Usually the line would not fit like this. There'd be a more drastic decrease in weight at these higher percentages, and the line would cross 0 somewhere between 1 and 0.5. But the point here is to show you how to do it, because this isn't real data, So do it with your data. Do the exact same process and see if your estimate is accurate. If it's somewhere between one of these values, it'll probably be somewhere between 1 and 0.5 for the isotonic point of potatoes. But anyways, that's just a brief tutorial of how to analyze your potato data. All right. For my lab sections, you're not turning something in this week. So I wanted to give you a tutorial of how to analyze the data. You do need to be able to interpret a graph like this and the equation for your lab midterm and lab final. So don't disregard it. Please give it a shot with your data that you generated in lab. And I hope to see you again very soon in class. Have a wonderful day. And that ends our supplementary recording. Goodbye.